Hello students, welcome to the chapter Differentiability. In this video, I am going to discuss derivative of composite functions. In relation function chapter, you studied that how to form composite functions of two given functions, and in continuity chapter, these composite functions continuity, and in this chapter you are learning derivative of composite functions, how to find derivative of composite functions. Before derivative of the composite functions, let me discuss some standard functions, composite functions, how we get. Okay, so let me discuss that one. Now I take one standard function x raised to n. X raised to n means the functions like x square, x cube, x raised to 5, x raised to 10. So such type of functions are, now I am saying, standard functions. See, these functions stand composite forms means very simple. This x variable, remember, now this x variable, what happens, changed by any function f of x. What happens? Composite function means x is changed by what? Any f of x, then raised to n. Okay, where f of x is any algebraic function or trigonometric function or etc. Okay, so then it become composite function of this standard function x raised to n. Okay, I will give you example. X square is a standard function, x cube, x raised to 4, x raised to 5, etc. These are standard functions. Okay, these standard functions, now I'm showing you the composite forms or composite functions. See, writing function like this, 3x plus 1 whole square. Whole square is become composition of x square only. But instead of x term, we have 3x plus 1 function. So therefore, this is called composite function of x square function. Okay, it may be any function inside the bracket, then whole square means it is a square function, composite function. Is it clear? Next, whole cube, x cube function, composite form. X is replaced by now another function. You can see that in the bracket we have which function? X square plus 1. So here it may be any function. Whole cube means it become x cube, standard functions, composite form. Okay, x square minus x plus 2 whole raised to 4, it is the composite of x raised to 4. X square plus x plus 2 whole raised to 5, it is the composition of x raised to 5 function. See, whatever the bracket, inside the bracket function, square is there means it is the x square function composite. If it is power 10 means it is a composite of x raised to 10. So inside the bracket, whatever the function. Okay, so it may be trigonometric also. For example, sine x whole square or sine square x. Sine square x means square is the main function, that is x square. X is replaced by sine x function here. Okay, in the same way, cos tan x plus 1 whole square, it is also composite of x square. Cos cube x. So cos x is now whole cube is the power, therefore it is the composition of x cube. X is replaced by what? Cos x function. Okay, so like this, if you see anywhere or in the example, you have to identify it is the composition of this main function, because it help you to write the derivative. Okay, so if you identify the first this one, then it become very easy to write the derivative of the composite functions. Okay, next is trigonometric functions composite forms. So trigonometric functions are sin x, cos x. Now these are called, now I say that these are standard functions. Now in these standard functions, if x variable, okay, sin x is a main function, x variable, if it is changed by or replaced by any f of x term, that means any function. Okay, so here you can see that very in this example, sine of f of x means here what happening, in one function another function act as a variable. Even in this example also, in one function, see square is one function, so in that x is replaced by another function means another function acting as a variable. Therefore these composite functions are also called as function under a function. In one function another function act as a variable. Okay, or it is also called as a, it is just like the function is like a chain system. The variable, in place of variable in any one standard function, the variable replaced by what, another function, the chain will be there. Okay, it is just like one chain system. Okay, in one main function another function will come means it is just like a chain. So this function holding this function like that. Okay, where f of x be any algebraic function or trigonometric function. Okay, here I am showing you some composite examples, composite functions. Sine 2x, see here, sine 2x, here this is called composite function now, because in sine x is main. In this, instead of x variable what we have, 2x, which means in x variable place 2x took the place, 2x function. So therefore sine 2x is called a composite function of sine x function. Okay, so this is now function. Okay, this is acting as a variable for sine function. In the same way, sine of 3x plus 1, other than x variable, if we get any function, it may be algebraic, trigonometry. Algebraic means we have many algebraic functions like x square, cube, whatever. In place of x, if that function comes means it is become composite function. Okay, sine of x square plus 1, sine of cos x, sine of tan x, sine of sin x plus 1, etc. I hope you understood these composite function. Okay, so just for identification I'm discussing this one. You have to identify whenever you see this function, this is a composite function of main function sin x, like that you have to understand. Okay, in the similarly cos x function composite form now. So in this cos x function, x is replaced by cos of f of x, cos of f of x means x variable changes to by any function. For example, cos 2x, cos 3x, cos 4x, or now I take different, x plus 1, cos of x plus 1, cos of x square plus 1. Now here in these examples, I changed the x variable by algebraic terms like 2x, 3x, x plus 1, x square plus 1. So even we can take trigonometric also, so cos of sin x. In any manner you can write that variable, cos of cos x, cos of tan x plus 1, cos of secant x plus 2, etc. All these are called as composite functions. Okay, in the same way, the remaining trigonometric functions, composite functions, are written like tan x is main, tan of 2x, tan of 3x, tan of 3x plus 5. Like that, if x is changed by any other term, then it become a composite. I hope you understood how to identify uh, trigonometric functions composite form. So next, another form is root f of x. Root x standard form. Root x standard form composite is given by root of any function. Okay, for example, root of x plus 1. Say other than inside the root, other than x, if any function comes, means it may be any function, algebraic, trigonometry, it may be any function, then it become composite function, and standard form or standard function is root x. Root of x square plus 1, root of x square plus x minus 1, root sin x, root cos x, root of tan x plus 1. See, all these are examples for these standard form, root x standard function, and these are composite functions. I hope you understood. So now let me go for definition, how to find derivative. Now these functions, composite functions, derivative of composite functions. Okay, now it is defined as, let y be a real valued function which is composite of two functions f and g. Now y is a composite function, it is composition of two functions f and g. That is, y is equal to f composition g, that is defined as f of g of x. See, here only you can understand, in f function g acts as a variable. G is a function act as a variable for f function, where g is a function of x variable. Okay, whenever it is composition of f and g, remember f is become function of g variable, means df upon dg. That means f function is differentiated with respect to g variable, and then into, and then g function is differentiated with respect to x variable. Okay, these two should be exist. Once again I repeat, g is act as a variable for f. That means f is become a function of g variable. Therefore, df upon dg, and g is a function of x variable, means dg upon dx. These two derivatives should be exist. Then derivative of y, that is composite function with respect to x, is given by dy by dx is equal to, okay, now derivative of that entire function, now it is defined in this way. It is very simple, df upon dg into dg divided by dx. Okay, once again I repeat, derivative of y with respect to x, that is dy by dx, is given by, that is equal to d by dg, that is derivative of f function with respect to g variable, into derivative of g function with respect to x variable. So it is a product. If you write this product, then it is called as a differentiation of y function. It is very simple, and this called as chain rule. It is very simple. See, derivative is followed like this actually. See, now f is the main function. This main function variable is what? G. Differentiate this f variable with respect to g variable only. Okay, that is df upon dg. Into, next is, this is composite. Okay, this is composite variable g, and this g is x variable function. No? Differentiate that one extra. Okay, so like one by one, first we differentiate f into, then composite. This is the technique. Once again I repeat, first we differentiate main function with respect to g variable, means composite variable only, into, then composite variable derivative. So this if we do it, then it become derivative of that entire function. Next is derivative of composition of three function. Let y be a real valued function which is composite of three functions f, g and h. Okay, here I show you the example for composition function of three functions. Sine of y is equal to sine of cos of 4x plus 1. Sine of cos of 4x plus 1. See here, one by one we have here. Cos of 4x plus 1 is become variable for sine function, and 4x plus 1 is become variable for cos. So this is composition of three function. In one functions, two functions are there, or acting as a variable. See, now this is f main function, this is g, and this is h, f of g of h. So this is the way of identification. Okay, that is y is equal to f composition g composition h, that is f of g of h, where h is function of x variable, and here df upon dg, because this entire g is now act as a f variable, for f function act as a variable, so therefore df upon dg. Next, dg upon dh, that is h is become variable for g function, means this g is differentiated with respect to h variable, and dh upon dx, that is h function x variable function, therefore d divided by dx of h function exists. Then derivative of y with respect to x is given by dy by dx is equal to, so now product of these three functions, that is df upon dg into dg divided by dh into dh upon dx. Okay, so how it is differentiated means very simple. First main function with respect to this g of h, see here once again I repeat, this f function now we have to differentiate with respect to this entire composite variable. Okay, f is differentiated by this entire variable, and into now g variable you have to differentiate with respect to h variable, and then into h variable, h function is differentiated with respect to x variable. Okay, once again I repeat, f function you have to differentiate with respect to this entire variable. Next, g function is differentiated with respect to h variable, and h function is differentiated with respect to x variable. So then if you follow like this, then it becomes derivative of that entire function. Okay, so these are the definitions, remember. Okay, now before okay, now I take the examples. Find the derivative of sine 2x with respect to x. So here, whenever you see the question, first function identify properly whether it is a standard or composite. Now sine 2x is composite function. Okay, so first or the question may be, if y is equal to sine 2x, then find dy by dx. Okay, the same it is. Okay, so always first you start with the writing. Okay, now I solve this example by definition method. Okay, afterwards we write direct method. There are different methods. Okay, so first I am writing the answer just taking g function, that is definition method. In this example, see, when always the composite variable, that we have to take it as a g function. See, sine 2x in this, which is the composite variable 2x, that you have to take it as a g. Then y becomes sine of g of x, because 2x is g of x. Okay, this entire now it is of f of g of x form. Okay, Now I'm going to differentiate y function. That means this one, y, sine of g. Okay, dy by dx is equal to, so by definition it is d by dx g, sorry, d by dg, because sine function variable is what? G variable now. So sine g, it is a function, therefore d by dg of sine g into now g function derivative, that is d divided by dx into g function. I hope you got it. So main function is a sine, in that which is the variable? G variable. Therefore sine function is differentiated with respect to g variable, and then into d by dx of g function. Okay, now let me write the derivative of the first term, that is a sine g with respect to g variable, means it become cos g. Okay, into, now I replace g by function 2x, because g of x is 2x. Now you have to differentiate this. So dy by dx is equal to cos gx. Gx means I take a 2x, cos 2x. Here derivative of 2x is nothing but 2 into 1, because I'm using here k into f of x. It is 2 as it is. X function derivative is 1. It is 2 into 1. So rearranging the term, it become an answer 2 into cos 2x. So this is the answer of given example, 2 cos 2x. The derivative of sin 2x is cos 2x. So in next I discuss the shortcut method, alternative method, how to write directly this answer. Okay, now alternative method, that is a directly I am writing the answer. First you write y is equal to sin 2x. Now directly differentiate. I'm not taking here g, and I'm not denoting a composite variable as a g. Okay, so differentiate, dy by dx is equal to, now see in this direct method, first main function is sine. No, what is a sine function derivative? Okay, it is a cos. So therefore you write first sine function derivative, that is cos. When you write derivative of main function, this variable you have to keep as it is. You should not differentiate. Only main function derivative, cos. Okay, and variable is same. Into, now differentiate this composite variable. Okay, so what it become? Differentiation cos 2x as it is. Now here we have again differentiation of 2x. 2x derivative is 2, or 2 into 1, sorry, 2. So the answer is, there only will get 2 into cos 2x. Okay, if I take one more example, you will get the idea how it is followed. Find the derivative of cos 2x with respect to x. Or if y is equal to cos 2x, then find dy by dx. Okay, students, again here composite is 2x, therefore take this function as g of x. I'm denoting 2x, that composite variable. See, if it is other than 2x, if any function is there, you take this function as g only. Okay, then given function become what? Y is equal to cos g, that is entire is f of g, f of g of x. Okay, now I'm going to differentiate y. See this y. Okay, so now cos g means, if you differentiate, you have to differentiate this cos g with respect to g variable only, that is d by dg of cos g into d by dx of g. Okay, this is definition. So now I'm writing derivative of cos g with respect to g variable, means minus sine g, and into d by dx of, here I am not differentiating g because it is x variable. Now I change this x g function to x function variable. sorry, I'm changing x g function to 2x. Okay, so this 2x you have to differentiate now. Minus sine 2x means g I replace 2x. Okay, here in this 2 is a constant, keep as it is, and x function derivative is 1, therefore it is become 2 into 1. So here I'm following the rule k into f of x. K as it is, x function variable, x function derivative is 1. So final answer is minus 2 sine 2x. Okay, now the same question I am writing directly answer. I am finding derivative directly. First you write y is equal to cos 2x, write differentiate with respect to x. Okay, dy by dx left side is equal to, see in this given example the main function is cos, 2x is composite variable. Now differentiate this main function with respect to 2x variable only, means composite variable. What is the derivative of cos? Minus sine, keep the 2x variable as it is, into, now you differentiate composite variable, that is 2x. It is just like I told, no, chain, one by one you have to differentiate. First I differentiated main function keeping this variable as it is, then this variable I'm differentiating. This is the method of following. Main function always first and then composite variable. Okay, next step is minus sine 2x as it is. So derivative of 2x is, just now I told you, it is 2, so it become minus 2 sine 2x. Same answer you will get. Okay, I will take one more example. See, these examples are not taken from the textbook. So first you have to understand this method of following, then I take the NCERT textbook examples. Okay, now let me take another example. If y is equal to 5 tan 3x, then find dy by dx. Okay, so first you write y is equal to 5 tan 3x, differentiate this one with respect to x. Here I am not writing answer using definition method, directly I am writing. So next onwards, in even in examination also you can write the derivative of the composite function directly, and in 1 mark section you will get the question on composite function only. They give one composite function, write its derivative directly, you have to write the derivative answer. Okay, so now here I am writing derivative of y function with respect to s, that is dy by dx is equal to, so in this example now we have 5 into 5 is a constant, so 5 as it is first. Okay, now what is tan a given function? Tan 3x, no? So main function is tan, 3x is composite. What is the derivative of tan? Secant square x, no? So first you write secant square. Say derivative of tan x is secant square x. So therefore tan function derivative is secant square, but here what is the variable of tan? 3x. You take that one into d by dx of 3x. I hope you understood how this derivative is followed. First main function derivative and keep this composite as it is. When you write the main function derivative, variable should be same, composite only. Then derivative of composite variable, that is 3x. Okay, in next step, write the derivative of this composite variable, that is 3 into 1, 3. So final answer is become 3 into 5 if you multiply 15 secant square 3x. So this is the way of writing solution. I hope you got the technique. Okay, next one more example. I take now combination addition form with algebraic terms. If y is equal to x square plus 2x plus 3 into secant 2x, then find dy by dx. Okay, what is the y function? given that y is equal to x square plus 2x plus 3 into secant 2x. Okay, now I'm going to write derivative of y function. So first d by dx of first function, it is a standard and a single term x square, therefore d by dx of x square plus, now 2x is also standard and it is a single function, therefore d by 2 as it is d by dx of x. So here I am using k into f of x, 2 is a constant outside, plus 3 is a constant as it is secant 2x derivative, that is d by dx of secant 2x. Okay, now wherever you have d by dx, you write the derivative. So d by dx of x square means it is 2x. Standard, it is not composite, it is the standard function, plus 2 as it is, derivative of x is 1. Okay, plus 3 as it is. Okay, now this is important. This is not standard function, this is composite function. So let me recall the derivative of standard function secant x. How it is written? Secant x into tan x. It is product of two function. In the same way you have to write, but in place of x you take 2x only. That is secant 2x into tan 2x. Okay, but it is not x variable, no, therefore into d by dx of 2x, composite variable. Main function derivative is written into composite variable derivative. Okay, for the next step is simplification. 2x as it is, 2 into 1 is 2, and here plus 3 as it is, secant 2x tan 2x as it is, because we have one more term here, differentiation. 2x derivative, it is also 2, or 2 into 1. So now next multiplying this 3 and 2, it becomes 6. 2x plus 2 plus 6 secant 2x into tan 2x. So this is the way of writing derivative of the given example. I hope you understood. Okay, now I give you some technique how to follow the derivative. The first one is, if we have any function sine of f of x, then its derivative is written like this: cos of f of x, means derivative of sine, first you write cos and keep this composite variable f of x as it is for cos function or for the answer, and into d by dx of f of x. So this is the way of following for composite function trigonometric form. Okay, sine derivative is cos, and then f of x as it is into d by dx of f of x. In the same way, for cos f of x, it is minus sine f of x into d by dx of f of x. Okay, so directly we'll get a derivative answer. So in previous example, I did the same technique. I followed the same technique. In this is tan f of x secant square f of x d by dx of f of x. See here, tan, this is composite variable, tan function, but composite variable. Tan function derivative is what? Secant square, and keep the f of x as it is, variable, and d by dx of f of x, that is a composite variable. Cot of f of x, if you have, minus cosec square f of x into d by dx of f of x. So here cot function derivative is minus cosec square, but what is the variable? F of x, the same variable it is taken. After that, d by dx of f of x, that is variable. D by dx of secant f of x followed like this: secant f of x into tan f of x. Okay, so previous example you can say that we have secant 2x, then answer is written secant 2x into tan 2x. Okay, answer, because answer of secant is that only, derivative of secant is, it is a product of two function. Don't ask sir how sir tan will come extra. Okay, it is the answer. Okay, in standard form I shown you secant x answer, derivative secant x into tan x. 2x is there mean just you write the 2x variable and into d by dx of that composite variable. Okay. Similarly, cosecant x composite f of it is given by minus cosec f of x into cot f of x into d by dx of f of x. Okay, so this is the technique you remember for trigonometric composite functions. Now I take one example from the NCERT booklet. If y is equal to sine of x square, then find dy by dx. Now dear students, you follow the same technique. Okay, y is equal to sine x square is given. Now I differentiate this with respect to x, dy by dx left side. Okay, now what is the main function? Recall this formula, d by dx of sine f of x. See, this f of x may be any. Now in this case, x square is the f of x. Okay, so what is the derivative is written? Cos of f of x, no, means cos of x square. Okay, sine term changed to cos, and then into this is f of x, no, that is composite d by dx of x square. Once again I repeat, sine x square is the given example or given function. So sine and x square is the composite variable. Sine function first write derivative cos x square as it is. After that x square function derivative. Cos x square as it is. Now you write x square derivative function 2x. So next rewriting this one, 2x into cos of x square. This is the answer for the given example. I hope you understood how the composite functions derivative is followed. So this example is from the textbook. Okay. Okay, you dear students, practice these following examples. That means find the derivative of these standard functions. So already I solved 5 examples. So whatever knowledge you got it from that, so trying to find out the derivative of these functions. Okay, thank you.